If you glue together a bunch of polygons to make a 3D shape, it's called a polyhedron. And one of the cool things is that if you count up the number of edges, vertices, and faces and fill them in this formula here, you always get the number 2. For instance, here with the cube, we've got, 6 faces, we've got 8 vertices and 12 edges, and go ahead and check that that works out in that formula. We can use this to solve pretty interesting problems. For instance, could I build some shape with triangles and pentagons if this is how many of each I had? Well, if I counted up like the building blocks that I have, each triangle is going to give us 3 edges, each pentagon would give us 5 edges, and so before we snap anything together, we're going to get 39 edges. But when you think about how they glue together, no matter how we do it, those edges are going to snap together in pairs, and so we can't have an odd number of building blocks. So this one, the answer is no. Now, in general, if you had 80 triangles and 12 pentagons, it is possible to build something. You can read about it here on Wikipedia. And in general, the way to show that something does exist is to actually construct it. Let's do a harder version of the first one. Now we've got 3 different types of shapes, and let's do the same thing. Let's figure out how many edges we have. Here we have an even number, and so when they snap together, when we divide that in 2, our 3D shape is going to have 37 edges. Now we started with a total of 14 shapes, and so if we use that formula down here, we see that we must have 25 vertices. But if you think about it, whenever you have a 3D shape, at every vertex, you have to have at least 3 different shapes coming together. And so if you have 25 vertices, each of those would originally have to be one of at least 75 vertices in your building blocks. And so since we only had 74 to begin with, you can count them up and see, this is an impossible shape to make.